Assalamualaikum and hello everyone, we are students from AS12040 and today we are going to present to you about gravimetric analysis. So before we start, I would like to introduce our group member, which is me, Kia. Second one is Husnina, third one is Erika, and lastly our gentleman, which is Faris. So without further ado, let's roll it.
Here is the introduction. So what is the gravimetric analysis? The gravimetric analysis is the technique in which the amount of an analyte or the ion being analyzed in a sample can be determined by converting the analyte to some product, which is the change of chemical states of the analyte where mass of product can be measured. Why do we use gravimetric analysis? In fact, gravimetric analysis was utilized to calculate the atomic masses of numerous elements in the periodic table with six-figure precision. Gravimetry leaves little room for instrument mistake and does not necessitate a sequence of standards to calculate an unknown. Then, what is the factor of gravimetric analysis? A common method of doing gravimetric analysis by precipitation, in which a precipitate is discovered by adding a reagent to the analyte. In a gravimetric analysis, the factors that determine precipitation deal with precipitate solubility, precipitate particle size, and contaminants in the precipitate. So, what is the example of gravimetric analysis? One of the examples is to determine the amount of barium present in the known sample of barium chloride. Barium chloride solution of unknown volume can be treated with sulfuric acid to form an insoluble complex of barium sulfate. This barium sulfate can later be used to estimate the amount of barium in the precipitate and subsequently determine the barium's mass percentage in barium chloride. What is the example of gravimetric analysis in real life? Gravimetric analysis can be used in real life for numerous users, such as monitoring lead levels in water for human consumption, which, if not monitored, could lead to lead poisoning and death.
Gravimetric analysis is a quantitative analytical approach that uses mass measurement to determine the amount of a given analyte in a sample. It is based on the mass conservation principle, in which the mass of the analyte is estimated through the separation, isolation, and weighing of a precipitate created by a chemical reaction. So, it has 6 types of gravimetric analysis theory, which are precipitation, filtration, washing, drying, weighing, and last one is the calculation. So the first one is precipitation. The analyte is converted into a solid, which is an insoluble precipitate, by adding a reagent that reacts with the analyte to form an insoluble compound. The precipitation reaction should be selective, ensuring that only the analyte of interest is precipitated. Second is filtration. Filtration is used to remove the precipitate from the solution, while the filtrate, which is the liquid, is discarded. The precipitate is collected on filter paper or a porous medium. Next is washing. The precipitate that has been collected is washed to remove any contaminants or soluble components. This procedure guarantees that only pure precipitate remains, and this will boosting the analysis accuracy. Next is drying. To remove any leftover water or moisture, the washed precipitate is dried. This is an important step since the ultimate mass of the precipitate is measured after drying. Then weighing. A precise and reliable analytical balance is used to weigh the dried precipitate. The precipitate's mass represents the mass of the analyte in the original sample. Then calculation. The mass of the analyte in the precipitate is used to determine the concentration or percentage of the analyte in the original sample. This calculation is based on stoichiometry and known reaction equations. Gravimetric analysis offers several advantages, including high precision, good accuracy, and wide applicability across different analytes. It is often used for the determination of metal ions such as calcium and silver in various samples. However, gravimetric analysis also have limitations. It can be a time-consuming process, and certain factors such as the presence of impurities or incomplete precipitation can affect the accuracy of the results. Additionally, gravimetric analysis requires a careful sample handling, accurate measurements, and adherence to proper laboratory techniques to ensure the accurate results.
So getting into examples part, these are the examples that I've searched for the precipitation. The first one is determine of sulfate in a sample. This method involves precipitating sulfate ions from a solution using a suitable precipitate agent, such as barium chloride. The precipitate, which is barium sulfate, is then collected, dried and weighed. The mass of the precipitate is used to calculate the sulfate concentration in the original sample. And the example number 2 is determination of chloride in a sample. In this analysis, chloride's ions are precipitated as silver chloride by adding a silver nitrate solution to the sample. The precipitate is then collected, dried and weighed. The mass of the silver chloride is used to calculate and the chloride concentration in the sample.
Next, we are going to look at methodology, which we have precipitation method and volatilization method. For precipitation method, it is a widely used technique in analytical chemistry for the determination of analytes. In this method, the analyte of interest is converted into sparingly soluble precipitate, which can be filtered and purified to obtain a product of known and stable composition. This product is then weighed to determine the quantity of the analyte present in the sample. To illustrate the methodology, let's consider determination of KBr, which is potassium bromide, in an aqueous solution using the precipitation method. The process involves several steps to achieve accurate and precise result. First, the sample of KBr is dissolved completely in water by adding it into a container and stirring until it dissolves completely. Next, an appropriate amount of AgNO3, silver nitrate solution, acting as the precipitating reagent, is added to the KBr solution. The following reaction takes place. As a result of the reaction, all the bromide ions in the sample form a precipitate of silver bromide, which appears as a cream-colored solid. To separate the precipitate from the solution, a filtration system is set up using filter paper and a funnel. The mixture of the solution and precipitate is poured through the filter paper, allowing the liquid to pass through while trapping the solid precipitate. The filter paper containing the precipitate, which is AgBr, is carefully removed from the funnel and transferred to a drying apparatus to remove any remaining moisture. After the precipitate is completely dried, the combined weight of the filter paper and precipitate is determined. To calculate the weight of the precipitate containing bromide ions, the known weight of the filter paper obtained before adding the precipitate is subtracted from the combined weight. Result provides the weight of the precipitate, which contains the bromide ions. Further calculation involves converting the weight of precipitate AgBr to moles using the molar mass of AgBr. By applying the stoichiometry of the reaction, the number of moles of bromide ions present in the sample can be determined. Overall, the precipitation method for determining analytes exemplified by the determination of KBr in aqueous solution involves dissolution, precipitation, filtration, drying, weighing, and subsequent calculation. These steps ensure accurate quantification and provide valuable information about the composition of the analyte of interest. Moving on, we are going to look at the volatilization method. This method is a commonly employed technique in analytical chemistry to determine analytes or their decomposition products by volatilizing them at suitable temperatures. These methods involve collecting and measuring the volatile product or indirectly determining its weight from the weight loss of the sample. To illustrate the volatilization method, let's consider the example of determining the content of mercury 2 chloride in a sample. The following steps outline the methodology involved. First, a known mass of HgCl2 is accurately measured using a precise balance. The sample is then placed in a heat-resistant container, such as crucible, and subjected to controlled heating. Gradually applying heat using a Bunsen burner or a similar heat source facilitates the volatilization method on of the analytes of interest. As the HgCl2 sample is heated, it undergoes volatilization, transforming into gaseous mercury compounds and chlorine gas. The chemical equation representing the reaction is: to collect the volatilized compounds, a cold surface or a collection of apparatus is positioned above the heated sample. The surface can be a condensation tube or a cooling coil where the gaseous mercury compounds and chlorine gas will condense and collect. However, in the case of HgCl2, the focus is on collecting the gaseous mercury compounds. The condensation process leads to the transformation of liquid droplets containing the condensed gaseous mercury compounds. These droplets are collected in a suitable container, ensuring that the volatile mercury species are captured effectively. Once the liquid containing the collected mercury compound is obtained, it can be subjected to further analysis. Techniques such as atomic absorption, spectroscopy, or inductively coupled plasma mass spectrometry can be employed to measure and analyze the content of concentration of mercury in the original sample accurately. Overall, the volatilization method exemplified by the determination of HJCl2 in a sample involves weighing the sample, heating it to induce volatilization, collecting the volatilized compound, condensing them on a cold surface, and subsequently measuring and analyzing the collected liquid. This methodology provides valuable insight into the content of analytes, allowing for accurate quantification and characterization in analytical chemistry compounds. These droplets are collected in a suitable container, ensuring that the volatile mercury species are captured effectively.
Hey, it's me again with the examples. So now are the examples of the volatilization. The first one is determination of carbonate in a sample. This method involves adding an acid to a sample containing carbonate ions, which results in the release of carbon dioxide gas. The involved gas is collected then and weighed, and its mass is used to calculate the carbonate content in the original sample. The example number 2 is determination of moisture content. In this analysis, the water content of a substance is determined by measuring the mass of loss after heating a sample to remove the water. The mass difference before and after heating provides the amount of moisture present.
So that is all from us. Thank you and bye.